Hello, my dear students, and welcome to your chemistry class. This is your teacher, CosmeRobalino, and today we are going to do a little something a little different. As you can see, this is your digital book online. So we are going to do a quick review of what we've been doing so far, so we can remember, and then we can take it from there, right? Okay, so let's see. What have we done? That's the question. What have we learned? What have we studied? Well, this is your book, and this is the index. The chapter number 1 is the properties of matter. Chapter 2 is reactions, and the chapter 3 is the chemistry of everyday life. So we've been dealing with the units, the unit number 1, and we are kind of in the middle of the unit number 2. So let's take a quick review, shall we? We studied the properties of matter. As you remember, we started seeing that matter is made up of atoms, and atoms are also made up of subparticles, right? And that was in the unit number 2. If you remember, we explored the periodic table where the elements are organized according to the number of atoms, the atomic number, which is given by the number of protons, right? So there you have the number of atoms with hydrogen, which is the number 1 and has only 1 atom. Okay, so that was our topic number 1, the periodic table. Then we started with our chemical bonding, right? And we defined the types of bonding that we have in nature, the covalent and the ionic bonding. We got ahead of ourselves, and we conducted an experiment in the laboratory to show what when we have a covalent bonding and when we have an ionic bonding. Then, going on with the book, we also studied how matter is classified, and we talked about elements, compounds, and mixtures. And we said which ones are in which circumstances we can separate the elements, right? Not the chemical elements, but for example, in a salad, you can separate, right? But when you mix other things like sugar and water, then you cannot separate so simply. You have to do a process. But we have also seen that when you are cooking pancakes, well, in that case, there's no way to separate the ingredients. Then we talked about how we can separate mixtures using chromatography, using the colors, and we conducted our experiment in the laboratory to separate water from salt using crystallization. Well, first we used filtration, and then evaporation, and finally crystallization, right? You may remember all these experiments that we conducted in the laboratory and were quite illustrative of the process. Then we went on to define the physical and chemical properties of matter. And first, we made sure that we did understand the physical properties, which is, I would say, easier to identify than the chemical properties. Then we continued still with physical properties, and in this unit we went back to review the ionic and the covalent bondings, the ionic and covalent compounds, and that's where we could remember our experiment, and you can see the graph over there. So this is the part where we conducted or answered kind of a quiz with all the concepts, and that's part of one of our exams. Then here on our online classes, right, we have been talking about chemical reactions and obviously chemical changes, right? Then we made a difference between the physical and the chemical changes. And as you can see in the images, there are some of the examples that we have seen on the videos. Here, for example, after zooming in the image, we can see the ice cubes, right? The typical example. Then crushing chalk. Remember, we also had an animated image of chalk being crushed, and also cooking, right? Cooking pancakes obviously is a popular way to illustrate the chemical changes. And here we have the key words. We haven't discussed the key words, but I am sure that you guys understand these terms such as chemical change, physical change, precipitate, and reversible, because that's what we have mentioned in our videos. So now we go to the next pages, right? Where we talked about observing reactants and products. And well, if you remember, right, one of the processes that we talked about was what happens with silver when it tarnishes, right? The chemical reaction that takes place when silver tarnishes. I'm going to zoom in so you can remember. First though, we did talk about balancing chemical reactions, right? So we said, for example, that when we mix hydrogen and oxygen, we obtain water, and the chemical formula is right here before we balance the formula, right? Before we balance the formula, and after we do balance the formula, we obtain what we have right here. And also what we were saying about silver plus hydrogen sulfide. What do you obtain? Silver sulfide plus hydrogen, and in other words, tarnished silver. So I'm gonna zoom out, and that's the video that we watched last. So now I'm gonna flip the pages. You know that there are some pages describing the experiments, but we are not going to concern ourselves with this matter at this point. But we can see that the next topic is comparing hard and software. Hard and soft water, right? So let's get to it, shall we? Okay, so let's zoom in so we can better appreciate our key concepts and our objective, the main objective of this lesson. Here you go. Comparing hard and soft water. So the objective is to distinguish between hard water and soft water. So we are going to see the difference. What are the key concepts? Well, if I may use a tool here, right? Let me see. So let's draw a rectangle so we can see where exactly where we are. So this is our objective, to distinguish between hard water and soft water. Okay, going down to the key concepts, we have that there are 3 of them, right? Okay, so the first key concept is that when 2 liquids combine, a solid sometimes forms and drops to the bottom of the liquid. Sometimes we have seen that in our videos. This new substance is insoluble and is called a precipitate. So there is no solution, right? There is no solution, like a problem. Key concept number 2. A precipitate is the product of a chemical reaction where there is no solution, right? So a precipitate is the product of a chemical solution, of a chemical reaction, and soap scum. A common example of a precipitate forms when certain minerals in hard water react with soap molecules. Okay, so this is a very interesting process, and we are going to describe it or discuss it in just a short while. So let's go to it, right? So precipitates and hard waters. Precipitates are insoluble solids that are deposited from a solution after a chemical reaction or a change in temperature. Precipitates can form when 2 soluble salts in a solution react to form 1 or more insoluble products. The insoluble product separates from the liquid and is called a precipitate. The solids produced in precipitate reactions are crystalline solids. Crystalline solids. We are going to check the key words in a moment. And they usually settle at the bottom of the solution, usually, but not always. The fluid that remains is called a supernatant liquid. Okay, supernatant liquid. The 2 parts, the precipitate and the liquid, can be separated through filtration. Here, I guess we are missing a little word. Through filtration, among other methods. Precipitation reactions can be used to determine whether or not a certain substance is present in a solution. So, if a certain chemical reacts with lead to produce a precipitate, for example, you can test water for lead, not lead, lead by adding the chemical and seeing if the precipitate forms. Precipitation reactions can also be used to separate elements. For example, to extract magnesium from seawater, right? We have been discussing seawater, so this is how you can obtain magnesium. The most common water problem in the home is water with a high mineral content or hard water, right? And this is very, very common in Cuernavaca. Hard water contains ions of magnesium and or calcium, and if these minerals build up on pipes and the water flows through them, the pipes can become clogged, blocked if you want, if you like, especially if there is a high concentration of calcium ions. These deposits restrict water flow and can cause boilers to overheat. That's the problem, right? A sign that you have hard water at home is the formation of limescale inside pans in which you boil water. So check your pans and your pots in your house, and if you see limescale, that's an indication that you have hard water. Hard water also reduces the ability to soap and shampoo to lather. Soap scum is the term for the sticky grayish wash precipitate that forms when soap reacts with the minerals in hard water. This soap scum makes rinsing very difficult. When you wash your hair and dishes with hard water, a white chalky scale or residue is often left behind, and you can check your shower, for example, or your sink in the kitchen. There are, however, some benefits to hard water. It often has a pleasant taste, and depending on the dissolved minerals, it may confer some health benefits. So hard water is healthy in one word. So homeowners that have hard water often treat the water to make it softer, which involves replacing the magnesium and calcium ions in the water with sodium ions. The result is obviously soft water. Soft water does not react with soap to form a precipitate, but it also does not taste very good. Detergents such as dishwashing and laundry powder are synthetic soaps that are designed to lather in both hard and soft water. Calcium and magnesium salts in the water also react with detergents, but they form compounds that are soluble in water, so no precipitate is produced. So here you have the key words: crystalline solid, filtration, hard water, limescale, soft water, supernatant liquid, and synthetic. Well, that's all for today. Thank you very much for your attention, and I will see you in our online classes.